Hey guys, I thought that I would explain number 3 on the practice test. This is the original problem, and as you can see on the left, you have to do a source conversion. Remember, voltage in series can be put as current in parallel, and current in parallel can be moved or converted to voltage in series. If you notice, the 8 volts on the right side cannot be converted, so we have to deal with that. So what's the first thing that we do is we have to define our current. So that's here on the board and it's red. I1 is V1 over 3.3K, and I2 is actually V1 minus negative 8 volts. So you have to distribute that on top, so it becomes V1 plus 8 volts over 4.7K ohms. Then we have to write our equations. Leaving equals entering. So we have I1 is leaving. Okay, when we look at this equation, what's leaving it? We have I1 leaving, I2 leaving, and 2 milliamps is leaving V1. Equals what's entering, which is the 3.03 milliamps. So we write our equation here. Remember, the I1s have to be on the left, the currents have to be on the right. So to take that 2 milliamps and put it on the other side of the equation, it's minus 2 milliamps, and then you subtract 2 milliamps there. So we're left with I1 plus I2 equals 1.03 milliamps. So now we substituted in what we defined as I1 is V1 over 3.3K plus I2, which we have previously defined as V1 plus 8 volts over 4.7K equals 1.03. Okay, so now we have to separate them. So we separate V1 over 3.3 plus V1 over 4.7K. Then we have to do 8 volts over 4.7K. Well, when we have to calculate that one, so 8 volts divided by 4.7K is 1.70 milliamps. So then we're back at this problem here. So since we have the current for that previous equation on the left side, we must subtract that from each side and then do our final equation of 1 over 3.3K plus 1 over 4.7K. All of that is V1 equals negative 0.67 milliamps, and that's the final equation. So then we can solve for our V1 voltage now using the conductance. Bye. Have a nice weekend.